All right, so today we're going to be looking at how we can solve systems of linear equations and using matrices, and we're going to get them into reduced echelon form in order to solve them more easily. So first, let's identify a roadmap. So first, we've got our equation, so that's going to be our system, and then we're going to convert that into a matrix, and then we're going to let's see, check my notes real quick. We're going to convert that into echelon form. Then we're going to convert that into reduced row echelon form. And then we're going to solve it. All right, so those are our steps. We have our system, we convert that to a matrix, we get that into echelon form by transforming the matrix. Then we have reduced echelon form by converting everything to 1, and then we can easily solve from there. All right, so let's start. It's probably easier to show with an example problem. So what we got here is u plus 2v minus w minus 2x plus 3y plus 0z equals b1. Then we've got x minus y plus 2z equals b2. Oh boy, this is a long problem. Okay, I'll probably skip this part. Okay, so first we got to start with the system, right? So here's our system over here. We've got all these variables that hurt my eyes, and then we're going to convert that into a matrix, all right? So let's make it so that it doesn't hurt our eyes, all right? So again, with a matrix, we're just grabbing all the coefficients, and then since we want this one to be an augmented matrix, I mean, well, actually, we don't actually know these endpoints over here, so yeah, let's make it an augmented matrix. Okay, so over here we got 1, 2, -1, -2, 3, 0, 0, 0, 0, 1, -1, 2, 2, 4, -2, -4, 7, -4, 0, 0, 0, -1, 1, -2, 3, 6, -3, -6. That's 7 and 8. B1, B2, B3, B4, B5. Okay. So from here, we want to get into echelon form. And so now, in order to get echelon form, we want to have this staircase sort of thing. And so what we can do is we can first get rid of the first variable. So in order to get rid of the first variable, we want to subtract equations that but also have this first variable. So we subtract b1 and b2. We can subtract b1 and b3 as well. So those are two options that we have. And also, since we already have these 3 zeros over here for these two rows, I want to move those towards the bottom just to simplify things a little bit more. All right. So let's just make a new matrix over here. I'm just gonna rewrite the top one. And then over here, we're gonna subtract from the first one times 2, okay? So we're gonna multiply the top by 2, and then we're going to subtract this. So 2 minus 2 is 0. 4 minus 4 is also 0. Negative 2 minus negative 2 is 0. Negative 4 minus negative 4 is also 0. Oh my. 7 minus 6 is equal to 1. Negative 4 minus 0 is just negative 4. Okay. All right, so we've done that one. We can also convert this one as well because we want to get rid of this first one. So we're going to multiply the top by 3 instead. Okay, so we have 3. 3 minus 3 is 0. 6 minus 6 is 0. 3 minus 3 is 0. Negative 6 minus negative 6 is 0. Oh my. 7 minus 9 is negative 2. 8 minus 0 is 8. All right. Then we can just rewrite these two. 0, 0, 0, 1, negative 1, 2. 0, 0, 0, negative 1, 1, negative 2. All right. And later we'll provide these B1 through 5s, okay? So now we see we've got all of these zeros over here. What we can do is further simplify because we're not in row echelon form yet. We want to get rid of even more variables. So first thing we can do is for this one over here, we can add these two together. We'll just convert the bottom one. So this bottom one's going to convert into 0, 0, 0. We're going to add these together, so we get 0. We're going to add these together, we also get 0. We're going to add these together, we also get 0. Wow, we've got a clear row over here. Okay, very nice. And then over here, we can also do this at the same time. So now this over here, since we only have this over here, we've got this what's called a leading variable. We can keep this row alone. We can leave this row alone. Now we want to get these two to be different. So we're going to multiply this top one by 2. So we're going to add these together. We're going to multiply this by 2 first, and we're going to add them together. So we get 0, 0, 0, 0. Negative 2 times negative 2 plus 2 is 0. 8 plus negative 8 is also 0. We got another 0 row, okay? So we're going to move that to the bottom. We'll do that later, but now we can just rewrite all these rows over here. Actually, let's just rewrite the whole matrix. We can go 1, 2, negative 1, negative 2, 3, 0. And then this row got to convert that. So we can write that at the bottom. We have 2 complete 0 rows over here. And then we get this one over here, 0, 0, 0, 1, negative 1, 2. Yeah. And then we can use this one over here. So 0, 0, 0, 0, 1, negative 4. And notice that I'm just reorganizing the rows. We've converted this row and this row to zeros. That's why they go at the bottom. Because when we have echelon form, we want to have our 0 rows in the bottom. And then over here, we've just rearranged these. Yeah, we've just rearranged these two. We swapped the orders around. All right, and now as you can see, we've got the staircase formation that we want, like that. They're only going down by 1, and we're skipping over all the zeros. All right, so there we have echelon form. But now we want to get to reduced echelon form. And so in order to do that, we need to make sure that every single 0 over here, so you see this is where leading variables are. These are leading variables because they're the first variable. We want to make sure that they're all 1, which is, luckily we already have that, so that's fine. But then next we want to make sure that every other variable in that row is also going to be a 0. So you notice that over here, this 2 is not a 0. And so we're going to have to do some some math to get that to 0. So what we can do is we can subtract this second row from the first row, or yeah, we can do that in order to convert this number to 0. Okay, so we're gonna do 1, 2, -1 because these are all 0, and we're gonna multiply this second row by 2 and add them together. So -2 plus 2 is 0. -2 plus 3 is 1. And 2 plus 0 is, the 4 plus 0 is 4, because we're multiplying this by 2. Right? Okay, now we've got that 0 here, and 1, -1, 2. Now we have this satisfied, which is good. But okay, next up, we're going to want to also satisfy this row over here to be in reduced echelon form. And in order to do that, we're going to multiply both of them, okay? -4, and it's going to 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So let's do one more transformation. Okay, so these ones we can just straight subtract. So we get 1, 2, -1, 0. 1 minus 1 is 0. And 4 minus -4 is 8. And then over here, we're going to add. Okay, so 1, then we can, -1 plus 1 is 0. That's -2. And over here, let's just keep it the same. Nice. And everything else over here is going to be a 0. All right, so this over here is going to be our row echelon form, because all of our leading variables are 1, and everything else in those rows is 0. So that's reduced echelon form. Very nice. So we'll notice that we have leading variables here, but what about these other rows that correspond with like V and W, etc.? Well, those are going to be our free variables, and free variables, they're basically like, it just means that they're colliding to form a line. All right, so we have an infinite number of solutions, or we potentially have no solutions, but we don't have a singular solution because we have the existence of these free variables. Basically, whenever we enter our solution for every single variable, we're going to include the free variables as a function, it's gonna be a function of the free variables. Okay, yeah. All right. So to get more specific, we are going to need to add like the actual values to make it an augmented matrix. So according to this problem set over here, I'm gonna rewrite the matrix. According to the problem set, we're going to set these equal to 1, -3. Wait. We'll just say, yeah, something like this, okay? And then over here, we're gonna have zeros. All right. So this is gonna be our reduced echelon form with the augmented matrix. So down here, since they're all zeros and they're equal to 0, that's fine. All right. These equations down here are perfectly fine. However, if it was not equal to 0, then there would be no solution, because that would be saying that 0 is not equal to 0, which doesn't make any sense. And so it's a good thing that these are 0, just for the example. All right, so now we can go ahead and start solving for these variables. So I'm actually going to write out what each one corresponds to first, just to like help out. And then over here, we're going to identify our free variables. So again, leading variables are at the ends. Free variables are everything else. So this would be free, this would be free, and this would be free. So now we can write this as a function of v, w, and z. All right. So we can say y. let's look at y first. So y is going to equal to, we subtract the z to the other side, so we get 2 plus 4z. All right, so that's what our y is equal to. Our z is just going to be equal to, since it's a free variable, we can just assign it to something else. So I'm just going to pretend it's like z1, but you can assign this to be t, a, whatever you want, like whatever it is. Next, we're going to look at x. So x is going to equal to negative 3, and we subtract this over to the other side. So that'd be plus 2z. All right? And then v is going to equal to v1, that free variable. W would equal to the free variable as well. So it'd be like w1. And see, these are going to be our variables in our final set, right? So we can put z1 over here. And over here, we get u. That's what we need to solve for. So we have u equals to 1, which is over here already, minus 2v, because we subtract to the other side, plus w. And these are zeros. We can ignore them. Minus 8z. All right. And there we go. Now we have a solution for every single variable. All right, and that's our goal with trying to reduce the system down to reduced echelon. We're able to more easily see how everything corresponds to each other. Now, of course, we'll have to find, like, maybe you can use this to like find certain values of v, w, and z. I guess that would work. But overall, we have the free variables at the end. And our answer is basically just lines for these variables. So I hope that wasn't too confusing. I hope that wasn't too confusing because this is my first time learning this too. But yeah, subscribe for more videos where I just write down what I learned. Okay, bye bye.